Hello there, ladies and gentlemen. I'm coming to you today from the comfort of my home. I'm obviously in class with you, but this video is at my home. So you can see a little bit of the rug back there. Oops, somewhere. There it is. The blanket. Yep, that's what we're sitting on. And I've got my blanket over my lap. All right, we're gonna get started though. First thing I want you to do, put your name on the top of your paper. Once you've done that, now I want you to listen and follow along as I read your I can statements. I can use scale drawings to find actual distances. I can find scale factors. I can use scale drawings to find actual perimeters and areas. I can recreate scale drawings at a different scale. So in case you didn't get all that, today we're doing scale drawings. Which means if something is originally this size, how can we redraw it this size or this size and have it be similar? Alright, so let's look at the actual definitions. A scale drawing is a proportional two-dimensional drawing of an object. This is D-I-M-E-N-T-I-O-N-A-L. Object. So, a scale drawing is a proportional two-dimensional drawing of an object. A scale model is a proportional three-dimensional model of an object. Proportional three-dimensional model of an object. A scale is a ratio that compares the measurements of the drawings, of the drawing or model with the actual measurements. And a scale factor is a scale, so it's pretty much the same thing, without units. It's a scale without units. So something says unit squared, doesn't have any actual units. Right? An example of a scale. If you had a drawing that had this ratio, 1 to 10, 1 inch to 10 miles. The drawing was an inch on the paper, but actually it was 10 miles in real life. So if a car drove 10 miles, we would represent that as an inch on paper. It's okay if you don't understand this yet, we're going to keep going over some of this stuff. I'm going to show you right here. Alright, looking at this map of Michigan, we're going to use our ruler to find the distance between Cadillac and Detroit. Cadillac is right here, Detroit is over here. That's where Mrs. Wensley is going this weekend, actually closer to Ann Arbor, but I'll be going between Detroit and Ann Arbor. Alright. We're going to measure it out. Looks like we're at about 3.5 centimeters. So then we're going to put them in this proportion. So up here, this part of our map, it says 1 centimeter to 50 miles. That means for every 1 centimeter we have on this map, it represents 50 miles across the state. Now we have 3.5 centimeters to get from Cadillac to Detroit. And we don't know the actual distance. That's what we're figuring out. So what I want you to do is use the cross products property. If you do not remember the cross products property, I'm going to review it with you. It is when we cross multiply. So saying 50 times 3.5 is equal to cross multiplying this way, which is 1d. 50 times 3.5 is 175. And 1 times d is just d. So this distance from Cadillac to Detroit, is 175 miles. Some of you may wonder how you can use the cross products property because you're multiplying two different units together. We have miles and centimeters. But because both are numerators, are the same unit, which is centimeters, and both denominators are the same unit, miles, it is okay to multiply. If the units were not the same in the numerators and were the same in the denominators, this could not be done. A quick way to explain. So one way to explain this is to use a simple problem. If a scale is 1 centimeter to 5 feet, then 2 centimeters would actually be 10 feet. So we would have 2 to 10. 2 centimeters to 10 feet. See how they both double? I did copy and paste this from the book, so it should be in parentheses. So I apologize about that. Now go ahead and try this on your own problem. Pause the video and give this a shot. Now we're going to look at finding the distance on a model. Right here we have a model of the globe. The liquid outer core of the Earth is 23 kilometers thick. A scale model of layers of Earth has a scale of 1 inch, so 1 inch over here is equal to 500 kilometers. How thick is the liquid outer core of a model? So the first thing we're going to do is we're going to set up our ratio. We have 1 inch per 500 kilometers. We're going to set that equal to some number of inches. We don't know how many inches are going to be in our model, but we know that we need it to be 2,300 kilometers. So this up here, this is our model. This down here, this is our actual. Now we're going to solve this ratio. We have 1 over 500. Keep your units, please. They are important. We're going to multiply by the 2,300 to get that x by itself. Because when we multiply it, that's the opposite of the division, then we get x by itself. Equals this times 2,300. Well, 1 times 2,300 is 2,300. 500 over 1 is 500. Cross out those zeros. That's the same as dividing by 100. When we divide by 100, we get rid of 2 zeros. So we have 23 over 5 equals x. Well, 23 divided by 5 is what? It is 4.6. Make sure you label so it's 4.6 inches. Please follow the same process, just like we did up here, for the on your own problem. Now would be the time to pause the video. You can re-watch what I just did. Now we're going to look at finding a scale factor. Finding a scale factor. The first little box, if you want to read it, is some fun information for you, but it does not have to do with math. It just has to do with this picture. A scale model of the Sergeant Floyd Monument is 10 inches tall. 10 inches. And it is, the actual monument is 100 feet tall. So we're going to do our model height over our actual height. So the scale of the model is, we have 10 inches over 100 feet. If we reduce that, we have 1 inch per every 10 feet. Now, if we have a scale, now write the scale with the same units using the fact that 1 foot equals 12 inches. 1 foot equals 12 inches. So down here we have 1 foot, 12 inches. We're going to use this model right here. So we're going to multiply that 10 by 12 to get 120 over here. So we have 1 foot equals 120 inches. Sorry, 1 inch. 1 inch is 120. That would be our ratio for our scale factor, because we have this 1 inch and 10 feet. Okay, so now we write the scale factor. We know that 1 foot is 12 inches. We already know this. So we have 1 inch over 10 feet. It's going to be equal to 1 inch over 120 inches. So we can cross out those inches, and it equals, da, 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 just 1 over 120. And the scale factor would be written as 1 to 120. Now I would like you to try number 3 as well. Please use the same fact that 1 foot is equal to 12 inches. Actually, this should have all been up there, so I apologize. Now right here, a drawing has a scale, I'll go ahead and go over this one with you guys. A drawing has a scale of 1 millimeter to 20 centimeters. What is the scale factor of the drawing? We have 1 millimeter per 20 centimeters. So this would be our drawing, This would be our actual model. Now we would set that equal to or rather, it would be the same as, I'm sorry guys, I am struggling with talking through my words. So if we have 1 millimeter to 20 centimeters, we know that there are 10 millimeters in a centimeter. We are going to multiply this by 10. So then we have 1 millimeter per 200 centimeters. And then we can, 200 millimeters. We set that equal to, so then it's 1 over 200 without the labels. We can cross those out. So then we have 1 to 200. Our scale factor would be 1 to 200. Now go ahead and turn to the next page. Finding the actual perimeter and area. Finding the actual perimeter and area. So the scale drawing of the computer chip helps you see the individual components on the chip. We are looking at A now. We're going to find the perimeter and the area of the computer chip in the scale drawing. When measured using our centimeter ruler, the computer chip should give us a side length of 4 centimeters. 4 centimeters. Since this is a square, up here our computer chip is a square, all the sides are congruent. Therefore, the perimeter is 4 plus 4 plus 4 plus 4. All 4 sides are 4 centimeters. Remember that this can also be written as 4 times 4 or 4 squared. And it equals 16. Now we find the actual perimeter and area of the computer chip. Remember that we have the same thing here. We have the drawing over the actual. So we have 1 centimeter to 2 millimeters is equal to 4 centimeters, since that's one of the sides, and we don't know how many millimeters. So we're going to use the cross products property to solve. 2 times 4, 1 times s. 1s equals 2 times 4, which is 8. 1 times s is just s. And that is 8. So the length of the actual computer chip is 8 millimeters. The perimeter of the actual computer chip is. We think about that. We can show you up here. So up here, we're going to have all 4 of these sides times 8 now. So it's no longer 4 times 4, it's 4 times 8. So 4 times 8, 32 millimeters. So the perimeter of the actual computer chip is 32 millimeters. If we were to figure out the perimeter of the drawing, we would find something different. So the actual area of this computer chip is going to be what one side is squared. 8 times 8, we would have 64 millimeters squared. Now please note, these are millimeters. Up here we had centimeters. So our scale drawing would actually be bigger than the actual computer chip is. The computer chip is 4 times 8 millimeters. This is 32 millimeters. Our scale drawing is 4 times 4 centimeters. This would be 16 centimeters. So our computer chip is smaller. And that leads us to the next question. Oh, sorry, I got ahead of myself. It does not lead us to the next question. We are going to compare the ratios below to the scale factor. Remember that 1 centimeter equals 10 millimeters. Now, our scale factor is, we're going to go back to what we had before. We have 1 centimeter over 2 millimeters. So if we have 10 millimeters, because we want to make them the same unit, since there are 10 millimeters in 1 centimeter, we have 1 centimeter here. This is going to be 10 millimeters to 2 millimeters. Now we can cross those out. We have 10 to 2. 10 divided by 2, we can reduce that and make it 5 over 1. So we would have 5 to 1. Now, the drawing perimeter to the actual perimeter. The drawing perimeter was 16 centimeters. The actual perimeter was 32 millimeters. If we were to reduce this, we would divide this by 16 and divide this by 16. We could get 1 centimeter over 2 millimeters. This is the same as 10 millimeters over 2 millimeters. 5 over 1. Oops, I apologize about that. I didn't write straight. There you are. All right, we see here that the scale factor in the comparison of the drawing perimeter to the actual perimeter are the same. Now the drawing area to the actual area. The drawing area was 16 centimeters squared, and the actual area was 64 millimeters squared. If we reduce this, we can divide by 16 and divide by 16 and find that 1 centimeter squared over 4 millimeters squared. Once again, there is oh my gosh. There is 10 millimeters in 1 centimeter. So we're going to break this apart. We're going to go 10 millimeters. No, we're not. Because this is squared. 4 squared would be 2. So we have 2 millimeters over 1 centimeter. And we're going to just put our squared out here. So now we have 10 over 2, which is 5 over 1 squared. Please write in your centimeters and millimeters. So the ratio of the perimeters is equal to the scale factor. And the ratio of the areas is the square of the scale factor. So the ratio of the perimeters is equal to the scale factor, and the ratio of the areas is equal to the square of the scale factor. So is the actual chip larger or smaller than the chip in the scale drawing? I already gave you the answer to that one. We know that it is smaller. How do we know that it is smaller? And explain your answer. We can explain it because according to the scale, one centimeter represents only 2 millimeters. So we were to take out my SD card and we were to redraw that with a scale factor, we could see that our picture drawing would be larger than my actual SD card, which is about this big. An SD card is the card that holds the information in my camera. Now these next ones are on your own problems. Please go through and try them on your own. Pause the video, go back, look through your notes. The process of how to solve these is in there.